Good afternoon, guys. We're the Lunar Excavation Robot Team. My name is Zen.
My name is Michael.
Mark Dawson.
There's some ladies there too.
Yes, I trust. Ladies and gentlemen. Next slide, please. All right, we're competing, or rather, we're trying to compete within the NASA Lunabotics competition. And this competition is basically NASA's annual robot competition where you have to mine simulated lunar soil, and then the main objectives is to So we have to design a robot that is able to collect a certain amount of lunar soil within a certain amount of time, and it has to have weight limitations, size limitations, as well as power consumption regulations, and even data frequencies as well. And this is in order for us to explore within the realm of robotics to see what we can do and what we're capable of learning, etc. The objectives, obviously, you see here we have a maximum weight for the robot of 80 kilograms. NASA has set this regulation where it depends on how many people are within each team. Since we have a 3-member team, our weight limit is reduced, whereas if we had a 4-member team, it would be increased. As you can see here, we have to collect 10 kilograms of this simulated moon soil called regolith, or BP1. It's made from dried lava flows, and they use powder into. And also the robot has to communicate, and it has to show the data usage as well as the power consumed. And we're hoping to get a fully self-autonomous robot so it could do everything on its own. However, if we're unable to do that, we could still pilot it to some degree, but NASA does reward better points for fully autonomous robots. And also, the operation has to be relatively dust-free in order to preserve functionality and weight. This is the course that we'll be operating on. There are 2 different teams competing at the same time. And on the left, the lower hand side, you see the 4 randomized starting positions. The middle is an obstacle course for the robot to traverse. And here is where the mining area is. Your robot will come here, collect the material, and bring that material back to these collection chambers on the left of the group.
All right, I'm going to talk a little bit about the design. Basically, we're trying to come up with a design that's pretty much dust-free to help save some of the motors and electronic components. We're thinking about using auger dredge. We're doing research on that for a shoveling mechanism. And the wheels, we're thinking about a track-based wheel system in order to get maneuver through the surface pretty well. As well as the bin, we're thinking about using a retractable bin that goes up and down with another mechanism to dump it once it gets to the top rate. And for the auger dredge, we're thinking about doing a planetary gear system so that as it turns, it both spins the shovel as well as scoops at the same time. And these are some of the previous designs that we're basing our design off of. This is one of FIU's previous designs, and this is one of the competition winners in previous years.
So how this affects, global, the world basically. As Zen mentioned, autonomy is what we're kind of striving for. And some of the main applications is in mining. In Western Australia, there's a huge deposit of iron ore, and Caterpillar and Komatsu are kind of at the forefront. This is an example of what Komatsu is doing. Basically, their trucks are fully autonomous. Basically, they get a signal from a computer. They all have GPSs. So there's a dumping site and a loading site. So they just go to and from, and everything in between the truck calculates and avoids, certain obstacles. So kind of using that kind of idea, that kind of technology, I guess, trying to put that into ours and be able to use that. And so this is just an example of the power supply that NASA will be providing. Just your standard jacks. 100. What we're using is a motorcycle battery, our robot. And this is just an example of our timeline of what we're trying to get done. Most of it will probably be done during the summer. And yeah, so that's our lunar excavation robot.